Hello, everyone. In this video, we're going to look at the notes and examples from section 3.6. And we're going to be looking at using integrals for computing areas and average values. So we see in this next example, example 3, tells us to find the area bounded between the graphs f of x equals x and g of x equals 3. So let's go ahead and graph those two functions so we get a sense of what this image should be looking like. So first of all, f of x here, f of x equals x. Well, that's just this straight line passing through the origin with a slope of 1. Should look something like this here. And then g of x equals 3 will just be our constant function through 3. So it should look something like this. All right, and we can label here. So here's g of x, here's f of x. So we want to find that area bounded between the graphs. And we're going to do this for when x is from 1 to 4. So let's find 1 and 4 on here as well. So 1 is here, and 4 is up here. So take a moment to pause the video and see if you can sketch in what area we are looking for. So again, we're looking for the area bounded between these graphs. So awesome, you should be noticing that we then look at this section here. We want to compute the area of this section and the area of that section. So just looking at the picture, can you compute what the area should be? Well, we see that we have one whole square here. So it's one whole. Then we have a half and a half. So it's another whole. So 2. Then we have a half. So it should be 2.5 square units should be that area. But how could we compute that area using our graphs? Well, one thing we can notice is if we look at the area under the curve G, and let's first just look between the interval from 1 to 3, because that's at this x equals 3, some behavior changes between our graphs. But if we just look between 1 and 3, then if we were to compute that area under the curve G, that's too much area, right? We only want this little triangle here. So we know how to compute this area. Well, we also know how to compute this area under F. We know how to compute areas under curves. So if we want to find just this green area, or just that original blue area, what we can do is find the area under G. That is that green area. And then subtract the area under F that we didn't want to count for. So what would that look like in terms of an integral? Well, that would be the integral from 1 to 3 of g of x, that area under G, minus f of x, that area under x. So again, for this particular example, we can just look at our graph and find that area. But when we're dealing with more complicated areas or functions, that's when we'll need a set of integrals. So this is giving us a practice of how we'd actually do that. All right, so now what about that last little triangle? How might we use integrals to compute its area? Feel free to pause the video if you want to try to work it out first on your own. All right, so if we look at it together, you'll see that now, well, f function is larger than g. So if we look at the area under f and the area under g, we can see that in order to just find that blue area, we'd need to subtract the area under g from the area under f. So what would that function or integral look like? Well, now we're looking from 3 to 4. And we have the function f of x minus what's under the function g of x. So that should be giving us those areas that we want. So let's go ahead and compute our functions for g and f here. So we would have the integral from 1 to 3 of 3 minus x dx minus the integral from 3 to 4 of x minus 3 dx. So let's go ahead and evaluate each of these integrals to find their exact numbers. So in this first part, we need to differentiate 3 minus x. So we get 3x minus x squared over 2. And we're going to evaluate at 1 and 3. Then we're going to subtract x squared over 2 minus 3x. I'm going to use a lot of parentheses again, just so everything stays in order and my negative symbols are all together. I'll do parentheses there. So now we evaluate. So I'm first going to plug in 3 to that first expression here. So I'd have 3 times 3 minus 3 squared over 2 minus, I'm going to evaluate at 1. So minus 3 times 1 minus 1 squared over 2. And so I'll just go ahead and continue that further. So here I get 3 times 3 is 9. I'm going to get 9 times, again, 3 squared is 9. So 9, oops, and that should be a minus here. 9 minus 9 squared, oops, 9 minus 9 over 2 minus 3 minus 1/2. So now I'm going to continue with the second part. So I'm going to subtract 4 squared over 2 minus 3 times 4. And from there, subtract 3 squared over 2 minus 3 times 3. Again, using a lot of parentheses here. So now notice that negative symbol comes in several places. First, I'm just going to bring it in here. So I'm going to get 4 squared over 2 minus 3 times 4 plus 3 squared over 2 minus 3 times 3, which is 9. All right, so we're doing a lot of arithmetic here, but nothing that you can't do. So let's continue to simplify. So here we get 9 minus 4.5 is 9 over 2. 3 minus 1/2 is 2.5, so minus 2.5. Minus 4 squared is going to be 16 over 2 will be 8. So I get minus 8 here, minus 12, which is going to be minus negative 4, so plus 4. Then I'm going to get a plus 3 squared is 9. So I get 9 over 2, which is 4.5 minus 9, which is going to be negative 5.5. Oops, and actually good catch, everyone who's following along, minus 4.5. So it's good just to really take things slow and use a lot of space here. All right, so now let's go ahead and combine some terms. So one thing I notice is I have a negative 4.5, negative 4.5. So that's going to give me a negative 9. And I have a negative 2.5 and a plus 4. So these 9s cancel out. So I just get 4 minus 2.5, which would be 3.5. And now what we looked at was that we should be getting 2.5. So something went astray here. So maybe you already caught it. If not, let's look at it together. So what I'm going to do is just back up a few steps. And rather than try to do all these integrals at once, I'm just going to look at each one sort of separately here. So I'm first going to look at this integral here. Now the integral here is from 1 to 3, g minus f. So I should just be getting 2 because we're just looking at that triangle there. So if we follow our work down, looks good here, evaluating 3, evaluating 1. So we do this computation, I get 9 minus 9 over 2. So that should be 4.5. Minus, and I have 3 minus 1/2, which is minus 2.5. When I do that subtraction, I get 2, which is what I want here, which is what I see when I just look at this triangle. So that first integral checks out, and we're all checking out here, so that looks good. So now let's take a look then at the second part. So we evaluate at 4, which we've done. Evaluate at 3, which we've done. So let's just take a really careful look at the computations we're doing here. So I'm going to erase this and make sure I'm just including that subtraction, and then we'll just bring in that negative later. Okay, so here's what we're looking at. So here 4 squared, 4 times 4 is 16. So 16 over 2 is 8. Minus 3 times 4 is 12. So I should still be getting negative 4 here. And then here I have 3 squared over 2, which is 9 over 2, which is again 4.5. And I'm going to subtract 9. So I should be getting negative 4.5 here. So if we look at that together, we get negative 4 minus negative 4.5. So the negatives cancel. So I should be getting 0.5, which is what it looks like from the picture here. So the error in our previous work probably came from when I was just combining too many things at once. So this says I'm going to subtract, and actually this is where it looks like the error is coming from. We want to add these two together. So we're going to combine the sum of these two areas. So that's probably where our issue was made. So we're going to add that all the way around, all the way down. And we add a 0.5. So in the end, the integral becomes 2.5. And this is the sum of those integrals. All right, thanks for watching, everyone. And feel free to go back and do this example on your own, maybe start afresh. Be careful when you're computing or when you're making your computations and when you're simplifying. And it's always good to double check and use your picture for reference. All right, thanks for watching.